Our next topic is the power measurement in three-phase circuits. So the following methods are available for measuring power in a three-phase load. The first one is the 3-wattmeter method. So the instrument used to measure power is what we call the wattmeter. In 3-wattmeter, 3 wattmeters are inserted, one on each phase, and the algebraic sum of their readings gives the total power consumed by the three-phase load. So this in delta, we have this one. This coil here is the ammeter, and the resistance or the coil across this branch is the voltmeter. So voltmeter and ammeter is the wattmeter. So 1 wattmeter per phase, as well as in this connection Y. The first wattmeter is connected to the line and connected to your neutral. And the wattmeter inserted in your second line or line Y is also connected in neutral, also in line B for RYB connection. So this is a three-phase or 3-wattmeter method. Second one is the 2-wattmeter method. So this method gives true power in the three-phase circuit without disregard or without regard to balance or wave form provided in the case of Y-connected load. The neutral of the load is isolated from the neutral of the source of power. If there is a neutral connection, the neutral wire should not carry any current. This is possible only if the load is perfectly balanced and there are no harmonics present of triple frequency or any other multiples of that frequency. This method can also be used for three-phase 4-wire system in which the neutral wire carries the neutral current. In this method, the current coils of the wattmeters are supplied from the current transformers inserted in the principal line wires in order to get the correct magnitude and the phase differences of the currents in the current coils of the wattmeter. Because in the three-phase 4-wire system, the sum of the instantaneous currents in the principal line wires is not necessarily equal to 0 as in three-phase 3-wire system. So we will discuss this two-phase or 3-wattmeter and 2-wattmeter method further later. The third one is the 1-wattmeter method. In this method, a single wattmeter is used to obtain the two readings which are obtained by the 2 wattmeters. This method can, however, be used only when the load is balanced. Let's have an example in wattmeter method. But before you watch this one, kindly watch the first video that I posted in our MVLE. So this is the example number 1. Phase voltage and current of star connected inductive load is 150 volts and 25 amperes. Power factor of the load is 0.707 lagging. Assuming that the system is 3-wire and power is measured using 2 wattmeters, find the readings of wattmeters, or what will be the reading of wattmeter 1 and wattmeter 2. The given here is the phase voltage, which is 150 volts. From there, our EA, EB, and AC are the following. So EA is 150 angle 0 from our reference. EB is 150 angle negative 120 volts. And EC is 150 angle positive 120. So here we need the line voltage for us to compute the power. So, kailangan natin munang isolve or kunin yung mga line voltage parameters. So, I already discussed this one in our previous videos that the angle between the phase voltage and line voltage is 30 degrees. From our line voltage equal to square root of 3 multiplied by E phase, that is square root of 3 times 150, equal to 259.807 volts. And EAB, or the line voltage EAB, equal to EA plus the negation of EB, that is equal to 259.807 angle 30. So you just substitute here the value of EA, which is 150 angle 0, minus EB is 150 minus EB, that is 150 angle negative 120 degrees volts. So take note that this one is our long method. Later on, I will also discuss to you on how to solve it in short method. So, long method muna tayo. So, EBC naman is EB minus EC vectorially, that is 259.807 angle negative 90 degrees. ECA is EC minus EA, that is 259.807 angle positive 150 degrees volts. For our line and phase current, since this is a Y connected load, the value of phase current and line current is the same, that is 25 amperes. So our theta is arc cosine of 0.707 equal to 45 degrees lagging. Our line currents now will be IA equal to 25 angle negative 45. Next one is IB equal to 25 angle negative 165 degrees. IC is 25 angle 75 degrees ampere. So, saan natin nakuha yung mga angles na to? That is when we draw the vector diagram. This is our phase voltage EA, and the current, the angle between the phase voltage and the line voltage, or phase voltage and the phase current, is the power factor. So that is 45 degrees with respect to its phase voltage. So phase voltage natin EA, ang angle between EA and IA is 45. The angle between EB and this is IB, is 45 degrees also. And EC and IC is 45. So, ang kailangan natin ay from the reference. So, what will be its angle? Ano yung angle ng IA, IB, and IC with respect to our reference? So, IA is, initially that is negative 45 degrees. When you read it counterclockwise. Or clockwise direction, clockwise. Negative 45. IB is negative 165 clockwise direction. So this is from the reference to EB is 120 to, and the angle between the phase voltage and the phase current is 45. So 45 plus 120 is 165. Negative is the direction. Next one is IC. So paano naging 75 to? So, from the reference to EC is 120. This is 120. And the angle between EC and IC is 45. So, 120 minus 45 is the angle of your phase current to the reference. That is 75 degrees. Okay? So, solving now your wattmeter 1. This one, our wattmeter is an instrument used to read the power of the system. For our wattmeter 1, the line current or the ammeter is connected to our line current A, and its voltmeter is connected to line A and line C. So the common connection of line A and B is your line C. Wattmeter 2 naman is yung ammeter natin is connected to line B, and the voltmeter is connected across B and C. This is our wattmeter 2. Also, you can put here our ammeter 2, and the ammeter will be in series with line C, and the voltmeter will be connected in line B. Also, the voltmeter here is connected in line B. So, magiging common naman nila yung line B. So, like this one. This is your line A, line B, and line C. Kung gusto mong ilagay dito yung wattmeter 1, connected to line B, and this will be your wattmeter 2. This is your voltmeter, and this will be your wattmeter 2. So, common naman yung line B. So, ganun din yung isa pa. Pwede mong ilagay dito yung wattmeter 1, and your common will be in line A. Okay? So, for this one, nilagay ko sa line A and line B. Now, how will we solve the power in wattmeter 1? So, since our voltmeter is connected in line A and line C, the power now will be equal to EAC multiplied by the current, which is IA, times the cosine theta, or the power factor. Remember, it is crucial not to interchange the subscript. Okay? So, kung ano yung common, siya yung mahuhuli sa subscript. So, like this one. Our wattmeter 1 is equal to our power 1, equal to EAC times IA cosine theta. Our theta, or the angle theta, is the angle between EAC and IA. So, ito yung common. So, ito yung nahuli. This is our formula for our wattmeter 2, EBC, IB cosine theta 2. So, yung common nila ay C. So, nahuli yung C. Hindi pwedeng magbaliktad tong dalawa na ECA. Okay? So, magiging iba yung masosolve mong angle dito kapag nag-interchange yung subscript. So, let's go back here. Wattmeter 1 is equal to EAC IA cosine theta 1. Theta 1 for wattmeter 1. So, EAC is 259.807. Our IA line current is 25. So, paano natin isosolve yung theta? It is recommended that you need to draw the phasor diagram. So, ito yung phase voltage natin na EA, EB, and EC. Ito yung line currents natin na IA, IB, and IC. And the line voltage is EAB, EBC, and ECA. Remember that from our previous discussion, the angle between the phase voltage and line voltage is 30 degrees. Okay? Natapos na natin yan. Ang kailangan natin is EAC. Ang given dito or nasa vector natin is ECA. So, we need to get the negation of ECA para maging EAC. So, this will be its negation. It is 180 degrees. Okay? And our IA is here. And we need to get this one, theta 1, the angle between EAC and IA. So, paano natin makukuha yung angle netong EAC from the reference? Since our ECA is 150 degrees with respect to our reference, ito, ECA is 150 degrees, and the angle negation of ECA to EAC is 180 degrees. So 180 minus 150 is equal to 30 degrees. So 30 degrees etong EAC and from the reference. So sana nandito yung ano natin, yung IA kasi 45 yan. So let's say ito ay 30 degrees. Kasi ito from reference to ECA is 150 and ECA to EAC is 180. So 180 minus 150 is 30 degrees. Nandito yung IA natin. This is 45 degrees. So the angle between IA and EAC, ito yung kailangan natin, theta 1. So 30 minus 45, that is 15 degrees. So wattmeter 1 will be 259.807 times 25 times cosine of 30 minus 45, that is 6,273.785 watts. So that is the reading of our wattmeter 1. For the wattmeter 2, we have EBCIB cosine theta 2. So EBC natin nandito, that is 90 degrees with respect to x-axis, and IB natin is here. So the angle between EBC and IB, since the angle of IB with respect to reference is 165, nandito siya. Yung IB natin is 165 with respect to x-axis, and EBC is 90 degrees with respect to x-axis, clockwise direction. So, magiging 165. Ito, 165 minus 90 degrees para makuha natin yung angle between IB and EBC. So, 259.807 times 25 times cosine of 165 minus 90. Equal to 1,681.075 watts. The total power now will be the sum of wattmeter 1 and wattmeter 2, equal to 7,954.86 watts. So for the short method, this formula was derived in the video that I posted. So, tan theta is equal to the square root of 3 wattmeter 1 minus wattmeter 2 divided by wattmeter 1 plus wattmeter 2. So, wattmeter 1 plus wattmeter 2 is the total power. We can solve that one by square root of 3 ELIL cosine theta. From our given parameters, the phase voltage is 150. What we need is the line voltage. So, we multiply that one by square root of 3 para maging line voltage. So, wattmeter 1 plus wattmeter 2, that is our total power, equal to 7,953.75. So, same lang din yung nakuha natin dito. And the theta now will be arc cosine of 45 or arc cosine of 0.707, that is 45 degrees. So, tan 45 is equal to square root of 3 wattmeter 1 and wattmeter 2 divided by 7,953.75. So wattmeter 1 minus wattmeter 2 is equal to 4,592.1 from this equation. So tan 45 times 7,953.75 divided by square root of 3, that is equal to 4,592.1. And ilagay natin tong negative wattmeter 2 sa kabilang equation. So magiging wattmeter 1 equal to 4,592.1 plus wattmeter 2. That is our first equation. And we already know that the total power wattmeter 1 plus wattmeter 2 is equal to 7,953.75. This will be our second equation. So substitute equation 1 in 2. We will get 4,592.1 plus wattmeter 1 from this equation plus wattmeter 2 is equal to 7,953.75. So we can get wattmeter 2 that is equal to 1,680.875 watts. And also wattmeter 1 is 6,272.875 watts. So it is just the same readings sa nakuha natin dito sa long method. So this is the short method, yung direct substitution na. And yung long method naman is para makita natin yung mga angles, and we can also draw the phasor diagram. Of course, in your activities, I will require you to solve the problems in long method. So, yung short method lang ay gagamitin nyo para ma-check yung mga final answers ninyo, kung tama yung ginawa nyo sa long method. Okay? Example number 2, we have in a balanced 3-phase 400 volt circuit, the line current is 115.5 amperes. When power is measured by 2 wattmeter method, one meter reads 40 kilowatts and the other is 0. What is the power factor of the load? So if the power factor were unity and the line current is the same, what would be the reading of each wattmeter? So we will solve first the required, yung unang required na what is the power factor of the load. So our line voltage here is 400 volts and line current is 115.5. The first wattmeter reads 40 kilowatts and the second one is 0. So what will be its power factor? From our formula, the total power is equal to wattmeter 1 plus wattmeter 2. That is total power of the wattmeter is equal to 40 plus 0. So the total power will be equal to the reading at the first wattmeter, that is 40 kilowatts. So total power is equal to square root of 3 ELIL cosine theta. So power factor is equal to cosine theta equal to 40 kilowatts divided by square root of 3 times 400 times 115.5. Our power factor will be 0.5 lagging when wattmeter 2 is equal to 0. The second problem is what if the power factor where unity and the line current is the same, what will be the reading of each wattmeter? So if our power factor is unity, what will be the value of wattmeter 1 and wattmeter 2? So I placed our wattmeter 1 at line A and it is common in line B. The wattmeter 2 is placed in line C and also common in line B. So our line voltage will be equal to 400 for EAB, that is 400 angle 30. This is with respect to phase voltage. Okay? And for phase voltage is in phase with our reference x-axis. So, yung angle between ng phase voltage natin and line voltage is 30 degrees. So, EAB is 400 since our line voltage na is 400. So, 400 angle 30 degrees volts. And you can get this one by EA minus EB. Ganto rin yung makukuha nyo. Yung EA mo is 400 divided by square root of 3 kasi phase voltage yun. So, it is important to know the relationship of the phase current and the phase voltage and the line voltage. So, sinabi natin noon na the angle between the phase voltage and the line voltage is 30 degrees. So, EBC again is 400 angle negative 90 degrees and ECA is 400 angle positive 150 degrees volts. While our line currents is equal to our phase currents kasi naka-Y connected. So, IA is 115.5 angle 0. So, angle 0 kasi ang power factor natin is 1. So, our cosine of 1 is 0. Okay? So, for IB is 115.5 angle 0 as well as your IC. So, since power factor is 1, therefore, the phase voltage and phase current are in phase. So, remember, this is not line, this is phase. Phase voltage and phase current are in phase. So, this is the vector diagram. This is our phase voltage EA, EB, and EC. And line voltages EAB, EBC, and ECA. Yung angle between the phase voltage and the line voltage is 30. Phase voltage and the line voltage is 30. ECA and EC is also 30 degrees. And phase voltage and phase current are in phase kasi power factor is 1. So, nag-in phase yung EA mo tsaka yung IA, EC and IC, and IB, and EB. Now, what will be the reading of Wattmeter 1? So, yung Wattmeter 1 natin naka-connect sa yung ammeter is IA, ito IA, and your voltmeter EAB. So, E, A, and common to B. While the other one is, yung current natin is IC and your voltmeter is connected in line C to line B. So, common nila yung point or line B. Now, your EAB is equal to 400 and your line current is 115.5. So, what will be its angle between your EAB and IA, that is your power factor. So, tignan natin yung EAB. Nandito yung EAB and yung IA. So, the angle between them is 30 degrees. Cosine 30. So, you will get 40,010.37. 115.5 times cosine 30. So, 40,010.37 watts. While the wattmeter 2 is ECB, IC cosine theta 2, ECB. Yung theta 2 natin ay angle between ECB and IC. So, nasan yung ECB? So, since this is EBC, the negation of your EBC is here. So, nandito. This is EBC or ECB, I mean. And we need the angle between EBC and IC. So, nandito yung IC. Paano natin i-compute yung angle between them, which is this one? This is your theta 2. So, yung EA natin, phase voltage EA and phase voltage EC is 120 degrees apart. Diba? And EA and ECB is 90 degrees. 90 to. So, 120 minus 90 is the value of your theta 2. So, means that is cosine 30 degrees. So, 400 times 115.5 cosine 30. So, same lang dito sa wattmeter 1. Equal to 40,010.37 watts. Therefore, we can say that if you have a unity power factor, your total power will just be divided by 2. So, diba yung total power natin, we can compute total power is equal to square root of 3 EL IL cosine theta. You will get here 80,020 watts. So pag power factor mo is unity, power factor is equal to 1. In 2 wattmeter method, the reading of wattmeter 1 and wattmeter 2 are equal. So, yung wattmeter 1 mo is 40,000 and the other one is 40,000. So, you will just divide this 1 by 2. Now, our total power here is just the sum of wattmeter 1 and wattmeter 2. That is equal to 80,020. You can check this one using the short method. So, long method lang yung gagamitin ko dito. But you can check using short method.